Hello, 7th graders. Today we are applying WKU to scale drawings. Look at number 1. Jonas was building a rocket. He first built a model rocket that was 10 inches high. How tall would the actual rocket be if he used a scale for his model of 2.5 inches for every 15 yards? Scale drawings applies to WKU like we were working on last week. So you can still use that same strategy. We're just relating most of the time some type of unit of measurement like inches and yards. So let's set up our WKU for this one. Okay, we're relating inches to yards for this one. What you have to make sure that you're careful of is what information is given and what is missing, just like we talked about last week with WKU. A lot of times your K is going to be your known scale. So in other words, they're going to represent something on a small graph or model to represent something in the real world. So in this case, 2.5 inches represents 15 yards on the actual rocket. So be careful on what they're asking for. He first built a model rocket that was 10 inches high. How tall would the actual rocket be is what we're looking for. So his model was 10 inches. We want to figure out what that would be. This would be our X for the actual rocket in the real world. Okay, we can still do our cross multiplication or cross products here. Remember that your calculators that you've been using are not the best with mixed numbers, so it's easier to change it to improper or a decimal. In this case, 2.5 is easy to change to 2.5, so that would be my recommendation there. So we're going to say 2.5 x times x, that is equal to 15 times 10. Remember, this is like solving an equation. Multiply these two together, which would be 150, divided by 2.5. Remember, you're dividing on both sides like you're solving for x, inverse operation. All right, let's grab our calculator. So 150 divided by 2.5. All right, x is equal to 60 yards. So the actual rocket in the real world would be huge, right? 60 yards long. Whereas his drawing that he made is only 10 inches. All right, pause the video here and see if you can try 1A on your own and set up your WKU. All right, let's see how you did. W, K, and U. Okay, for Carson's, we're relating centimeters to meters. Okay, our scale, what we know is that 1.5, which again we're going to use 1.5, is equal to 12 meters. So now we'll set up a proportion. 18 centimeters, got to go on top, over x. All right, let's try our cross multiplication. So 1.5x is equal to 12 times 18. Okay, again, multiply these two together, and that would be 216. Okay, I'm running out of room to show my steps, so remember what we're doing is dividing by 1.5 on both sides. So 216 divided by 1.5. 144, and that's in meters. All right, let's take a look at 2 and 2A. These are a little bit more in depth. They take a little bit more steps, but I know you can do them. A rectangular playground is being built. A scale drawing shows that the length is 8 centimeters and the width is 5 centimeters. If the scale for the drawing is 1 centimeter for every 4 meters, what is the area and perimeter of the actual playground? All right, well, let's draw a little picture of this. So we've got a little model of the playground, length of 8 centimeters and width of 5 centimeters. Okay, so this part is kind of like our little drawing. Okay, the actual playground in the real world, we're just going to make like a bigger rectangle, but again, in the real world, it's going to be humongous, right? Okay, so our actual playground, we need to figure out using our scale. Now, I'm going to set up some proportions here, but you're going to see how this one's a little bit easier to utilize scale factor for. Take a look at this scale. 1 centimeter, 1 cm, is equal to 4 meters. So if it's 5 centimeters over here, let me change colors real quick. If it's 5 centimeters over here, what number would work? Remember, we're trying to figure out how much it was being multiplied by, like a scale factor. Okay, so think about how much we'd be multiplying by. Okay, if you were thinking timesing by 5, yes, you are correct. Timesing by 5. So 5 times 5 . Okay, sorry about that delay there. So times 5 would give us 20 here. So 20 centimeters. All right, let's set up another proportion for, use purple maybe here. Another proportion for the 8 centimeters. So we have 8 centimeters on the length here. So we're still going to use the same scale. So 1 centimeter, I might need to stick with black there. 1 centimeter to 8 meters, to 4 meters. 4 meters. Trying to figure out for 8 centimeters how much that would be. Okay, so again, going across here, our proportion times by what? If you were thinking times by 8, yes. So 4 times 8 would be 32 meters. I need to change that as well, 32 meters. So this one needs to change to meters. Sorry about that. Okay, so we're not quite done at that point. Okay, we also need to make sure that we read the question to get the area and the perimeter of the actual figure. So remember that the area we get by doing length times width. I'm going to steal some space from up here. So area is length times width. So for this one would be 32 times 20, which is 640 meters squared. And then perimeter is adding up all the sides. So remember, that means we need to go all the way around the whole figure. Let me highlight that for you. Remember, every side, 32, 32, 20, and 20, all added up together. So 32, 32, 20, and 20 all together is 104 meters. All right, seems like a lot of steps, so that's really what they're going to probably ask you guys for as 7th graders. So pause the video here and see if you're able to try 2A on your own. All right, let's check over our answer for 2A. So let me show you what you should have done, and you can check over your answer. Okay, here's our perimeter and our area. It was a 5 by 9 originally, but it should have changed to a 30 by 54. 30 by 54. Okay, if you were able to get that, great. If you were not, please jot down that answer so you have it correct. And I do want to point out, guys, that the way that I solved it for this one for 2 with the proportion, that is one way to do it. But this is also showing you another way using the 4 meters. You see how you can also use the times 4 to go across instead of doing a proportion every single time. Some of you might find that easier, or you might have already been thinking that. Okay, let's move to some geometric shapes for the next part. So at the bottom of your page are 2 triangles. So whenever we're doing scale drawings and scale factor, a lot of times they like to use shapes, and that's what your work is going to be about today. But you can set up a proportion, kind of a WKU, in a different way. So look at these triangles. You can kind of see how, let me use some fancier colors here, how the 4 and the X kind of say are corresponding or matching. Just like on this one, the 40 and the 16 are matching. So now we can do the same thing for the 6 and the 15 and the 45 and the X. So you basically can set up a proportion. You can relate the red to the blue. So it's kind of like putting colors in order. So red to blue. So we could say 4, right, over 6 is equal to x over 15, and cross multiply. Okay, see if you can set up a proportion for this one with red to blue. Okay, we're going to come back to that. I want you to go ahead last in this video and look at your work for today. It's the termite puzzle. So this one's going to ask you to set up proportions using scale drawings. So basically these similar figures are either larger or smaller. So do the same thing with setting up a proportion. 9 and 12 are matching. Right, 6 and x are matching. So we can set up a proportion to solve. 9 over 6, red over blue, equals 12 over x, red over blue, and cross multiply. So 9 times x equals 6 times 12. 6 times 12, of course, is 72, divided by 9. X is equal to 8. Going to find it over here and cross it out. Only what's left will answer the riddle. Be careful on some towards the bottom. You might struggle a bit more on the word problems, but don't let those throw you off. All you've got to do is kind of draw a picture for some of them. So for example, number 9, we've got a flagpole, and it casts a shadow that is 10 foot long. We've got a man standing beside. He's 6 foot tall and casts a shadow of 4. We're looking for how tall the flagpole is, right? There's our X. So again, think about doing colors again in your mind even. Height of the flagpole, height of the man. Shadow of the flagpole, shadow of the man. Remember, you're just setting up a proportion, making sure that everything matches. All right, give your work a good effort today and let your teacher know if you need any support.